Hi, okay, we have Lara joining us now. Hello, good afternoon, everyone, and welcome to this seminar. Thank you for joining us today. My name is Xiao Li. I'm a senior researcher from TSU, and I'm very honored to be the moderator for this event. So as you may know, this seminar is part of the TSU 50th anniversary seminar series. And today we are very fortunate to have Professor Milena Büchs with us as the guest speaker. Milena is Professor of Sustainable Welfare at the University of Leeds. Her research focuses on sustainable welfare and just transitions. She has published widely on the relationship between economic growth and welfare states and the question of how welfare states can be transformed so that everyone's needs can be achieved within planetary limits. Before joining the University of Leeds, she was a lecturer and associate professor in sociology and social policy at the University of Southampton. And today, Milena is going to talk about air travel inequality and distributional impacts of flight taxes. So I'm personally very looking forward to your presentation, and I hope you all will enjoy it. Just a very quick reminder that this seminar will be recorded and published online. So if you have any concerns or feel uncomfortable being recorded, please do let me know. And if you have any question to Milena later, so feel free to type in your question in the chat box, or you can just click the button to raise your hands up. All right, without further ado, please join me in welcoming Milena to give her talk.
That's great. Thank you so much, Xiao, and everyone involved in sending over the invitation. It's a great pleasure to be here, and I'm sorry that I can't be with you in person. That would have been really nice, but it was difficult to make it work from an organizational point of view. So like Zhao said in the introduction, even though I have done quite a lot of research on sort of sustainable welfare, I have always been really interested in inequality and carbon footprints. And so this research here on air travel is sort of a little sidetrack of my research, which I'm really happy to share with you today. So I will talk about basically about two papers that we published recently. They have both been co-authored with Giulio Mattioli, so really important to acknowledge his contribution to this research as well. And so I will talk about it from a just transitions perspective and ask how air travel inequality has changed over time and talk about the distributional impact of flight taxes. So, sorry, I need to move this around a little bit. So, actually, one other quick point before I start, just to pre-warn you that I have a cat, and even though my door is closed at the moment, there is a slight chance that he might come in and meow in front of the door. So in that case, I would have to open it again, just to pre-warn you that that might happen. I hope it doesn't, but yeah, let's hope for the best. So, like I said, I will discuss how unequally air travel is distributed in the UK and how that has changed over time. With this one, we were particularly interested in the impact of the recession 2007-8. Unfortunately, we published the paper and worked on the data with data before the pandemic, so we couldn't look at the impact of the pandemic. And then the second paper, like I said, is about the distributional impacts of air travel taxes. We come to this from a just transitions approach, so I will briefly explain what that means. We'll then, of course, explain the methods and the data, present the findings, and then discuss some policy implications. So just transitions is a policy principle that the transition to climate neutrality needs to be socially just and inclusive. This concept has actually initially been developed by the trade union movement already in the 1970s and 80s to highlight workers' rights within sort of more structural economic transitions, like, for example, the decline of coal production and steel production in Europe. But the term of just transitions has been revived more recently in the context of the green transition to highlight, the impacts that this transition would have on workers in high carbon sectors. And of course, it has now been widened to really look at making the transition as just as possible for disadvantaged people in society. There are a range of other related relevant concepts, concepts like energy and climate justice, which often distinguish different dimensions of justice, for example, distributional, procedural, and recognition justice. And here, especially when we talk about taxes, we are most interested here in the dimension of distributional justice. So when it comes to climate change and distributional justice, I often like to summarize it in this way, that when we look at the distribution of responsibility for climate change, i.e. Historical and current responsibility for emissions, the capacity to adapt to climate change, the cost of the transition, and the impacts of climate change, we see this sort of paradox distribution that the rich and privileged sort of people and countries have the highest responsibility for climate change and capacity to adapt, certainly compared to poorer and disadvantaged people and countries, and especially future generations. While when we look at costs and impacts, the distribution is sort of the other way around, where often the cost for climate change mitigation, that poorer and disadvantaged groups and countries bear higher burdens for that, certainly in relative terms, than richer people and countries. And the same applies to climate change impacts. So that constitutes sort of one of the injustices when it comes to distributional impacts of climate change and climate policies. And that's sort of, the general idea, I suppose, that we started from. So the papers that we developed here were part of the Center for Research on Energy Demand Solutions, which ran for 5 years and has just sort of come to an end. I was part of what we called the Access team, sort of informally, at Leeds, which was led by Gillian Annabel at the Institute for Transport Studies, even though we didn't only focus on transport, but we ended up sort of focusing, or writing quite a lot of papers on transport-related issues. So we were interested in this team, in the concept and in measures of excess energy use. We have not, I have to disappoint you, come up with a very clear sort of definition of what excess energy use actually is, because inevitably discussing about what excess is involves normative judgments about what is needed, what is luxury, how needs and luxuries are distinguished from each other or distinct from each other. So I think it comes down to, saying that these sorts of decisions will always rely on deliberative decision-making processes and collective decision-making to sort of really come to agreements. Often, I think they will be locally contextualized agreements about how we define needs and luxuries. Nonetheless, I think there are some ways in which we can identify high or very high energy users. So, for example, borrowing methods from inequality research, where, the top, let's say, 10% or 20% of energy users are identified. This is sort of one legitimate way, I think, to look at high energy use. And some of these measures we have also used in this paper on the inequality of air travel. So air travel then in particular is an area of concern because global demand is predicted to increase rapidly, which is likely to challenge the achievement of climate targets. And air travel, as you probably know, is harder to decarbonize than some other types of travel. So, so these two questions are relate to these two papers that are here on the slide. So the first about how unequally air travel is distributed in the UK and how this evolves over time was published in 2021 in Travel Behaviour and Society. And then the second about the distributional impacts of air travel taxes in the Journal of Sustainable Tourism at the end of 2022. So in contrast to motor fuel and domestic energy, there are currently no taxes on aviation fuels internationally due to the 1944 Chicago Convention. This is another sort of interesting piece of fact when it comes to air travel taxes. However, countries can implement taxes just within their own country. So, for example, the UK has the air passenger duty, but it only applies to flights that leave from the UK. So which data and methods do we use? For the first paper, we used measures on the number of flights from the Living Costs and Food Survey from 2001 to 2017-18, and the National Travel Survey from 2003 to 2017. So these periods are chosen for the availability of the number of flights in these data sets. There are some, so we use these two surveys because both of them have slightly different sort of versions, let's say, of how they collect this information on number of flights. So, for example, the LCF only has leisure flights, while the NTS also includes business flights, which is around 12% of UK flights. So measures of inequality slightly differ between business flights and leisure flights, as we can see in the results. And also the NTS only covers England, whereas the LCF covers the whole of the UK. We examined inequality, looking at the Gini coefficient, which is a common measure of inequality. And we also looked at inequality over income deciles and over time. And then for the second paper, we used the Living Costs and Food Survey 2014 to 2017-18, the secure access version, which actually includes flight destination countries for up to 16 flights per household per year. And so that enables us to generate more precise estimates of emissions per flight, which previously with the other data set we can only do in quite a coarse way, because the non-secure access version only distinguishes between UK flights, short-haul flights, and then long-haul flights. And so obviously, while you can still apply a sort of average emission factor to these distances, it will inevitably be quite coarse. So that was a nice opportunity to actually use that sort of richer data set to model flight emissions, and then use that for calculating flight taxes. The emission factors come from the DEFRA greenhouse gas emission factors database, and yeah, we use sort of the average factors there for long haul, short haul, and also class factors. And then in addition, in that paper, we also use Understanding Society, the Understanding Society survey 2018-19, to examine characteristics of frequent flyers, because we wanted to know, which types of people might be most affected by travel taxes, air travel taxes, and what can we then conclude from that from a justice perspective. Okay, so moving on to the results. The first thing to highlight is possibly to say, well, how important are air travel emissions actually? Because you might say, well, air travel emissions only make up a small proportion of a household's carbon footprint. But it really depends on how you're looking at this. So on this graph here, we can see the carbon footprint for households, who sort of the average carbon footprint from flights for households, then the carbon footprint for households with one flight, and for households with two and more flights. And you can see the carbon footprint increases quite considerably depending on the number of flights that you have as a household. It's probably more informative to look at what is then the proportion of air travel emissions in your total carbon footprint, where we calculated the total carbon footprint, including emissions from everything else, so including home energy, food, and all other goods and services that households consume. Again, we used emission factors from the UK MRIO model that my colleagues Anne Owen and John Barrett work on to calculate these emissions. So basically, average household emissions per year are about 25.7 tons for the UK. And so for an average household, flight emissions make up 8% of that carbon footprint. If a household has one flight, that already increases to 18%. And for households with two flights, actually nearly 30% of the whole household carbon footprint are made up by air travel emissions. So this is quite a high proportion. So looking at air travel inequality, this here presents the inequality of air travel emissions expressed in a Lorenz curve. I hope you are familiar with Lorenz curves. It's quite a sort of conventional way of basically presenting the distribution of something in the population. It could be income. In this case here, it is emissions. So I can briefly explain how this is created. So basically, we have two axes. On this axis, we basically just we have households starting on the left-hand side with the household with the lowest emissions and ending up with the household with the highest emissions. And then we can just simply compare the cumulative population percentage with the cumulative percentage of flight emissions. And what we can see, so if flight emissions were equally distributed, we would see basically this 45-degree line. The fact that these two curves, so for all flights and for frequent flights, are quite far away from this 45-degree line shows us that flight emissions are very unequally distributed in the population. So, for example, the bottom 80% of the population actually does not have any frequent flights, and only about and they only have about sort of 16 point, I think off the top of my head, 16.1% of all flights emissions. Yeah. If it was obviously equally distributed, they would have 80%. Yeah, so I hope that makes sense. And so in that sense, yeah, we can see how very unequally air travel emissions are distributed. Also, it's informative to look at the distribution of emissions and number of flights over income deciles. Here we see the distribution of the number of flights for all flights in dark gray, and light gray has the frequent flights. So what's interesting here is that even though we see, generally speaking, an increase over income deciles, the lowest income deciles actually has a slightly higher average number of flights and frequent flights compared to the second and third income deciles. And we will see later that that affects the distributional outcomes of air travel taxes. However, when we look at emissions, we see a more sort of steady increase of emissions, both for all flights and for frequent flights over income deciles. So here are some more numbers to sort of highlight, the inequalities here in air travel emissions. So, for example, the top 5% of emitters are responsible for 40.2% of flight emissions. The top 10% are responsible for 60.8%, while the bottom 80%, this is what I just said, are only generating 16.1% of all flight emissions. So we can see this kind of quite vast inequality. Also by income, we can see inequalities. quite stark inequalities. For example, households in the lowest income decile have mean annual flight emissions of 0.63 tons, while households in the top income decile have emissions of 4.73 tons per year. So this is 7.5 times as much. And if we look at frequent flights, the top income decile has 15 times more emissions than the lowest income decile. So a few words then about how air travel inequality has developed over time. Here, this is just the first graph to see how participation in air travel has actually developed between 2001 and 2018, I should say. So at some point, the LCF switched to a financial year round. This is why this actually, the last year, includes households from 2018, just for, to make this year easier. We have put this as 2017. What we can see is it goes up and down a bit. It decreases after the 2007-8 financial crisis and then rises again. But if we just compare the start and the end point, we can see an increase of about 8%. So 8% more of the population have at least one flight per year. And when we look at the inequality of that, so expressed as the Gini coefficient of flights in each year separately, and I would like to focus here on the LCF graph, even though the NTS graph is similar, but it's based on individual data actually, whereas the LCF here uses household data. What we can see is, again, we can see inequality has increased after the recession and then fallen again. But if we again compare the start point and the end point, inequality in air travel participation has slightly decreased. So we looked at this in a little bit more detail to see, what about disadvantaged groups like low income groups or people with low education, for example. And we can see that they have certainly participated in the expansion of air travel over time. In fact, the percentage increase among the lowest income decile of people who have flown is roughly the same as in the overall population. But interestingly, the share of flights made by the lowest income quintile has slightly increased over time. And so this is why we see this reduction in inequality. It's also informative to look at what's called the income elasticity here. So to see how participation in flights responds to changes in income. And what we can see is that, flight activity is highly responsive to changes in income. So, for example, participation among the lowest income group has fallen much more during the 2007-8 recession and increased more after the recession compared to higher income groups. Showing that, even though we see, generally speaking, high elasticity, it is greater in relative terms for lower income groups. But in absolute terms, richer groups have reduced more during the recession and increased more after. So if we look at the total number of flights, richer groups, like I said, have reduced much more and increased more after. So it is important, I think, still to bear that in mind. Okay, moving on to modeling air travel taxes then. So, all this discussion obviously highlights, as we've seen, air travel is highly unequally distributed. Sort of raising the question, could that be a candidate for raising air travel taxes to try and incentivize people to switch to lower carbon means of travel or reduce air travel in the first place? So what we did in the paper is we modeled 4 different types of taxes, with and without including the first flight. Here I present the results for excluding the first flight, but the other results are also in the paper, in the supplementary information. So we modeled the UK air passenger duty, the 2021 version. of it, which basically has different rates depending on the distance and the flight class. Then we model a fairly sort of basic flight emissions tax, which we define as a 50-pound tax per ton of CO2 from air travel. And then thirdly, we model a frequent flyer levy based on the model that was proposed by the New Economics Foundation and We Are Possible in 2021. And that one puts 25 pounds on the second return flight, and then the charge increases by 10 pounds for each additional flight. So yeah, the frequent flyer levy is basically not just looking at emissions, it's actually more focused on the number of flights and tries to disincentivize frequent flying in particular. While it says, maybe one flight could be okay, we can, we only start charging people after the first flight. So happy to discuss about this because they're interesting sort of, I guess, implications here for, how we treat air travel. And then finally, we modeled the frequent air miles tax. That's our term for it, which was proposed, however, by Fouquet and O'Gara in 2022. And so basically, the frequent air miles tax is a combination of a carbon tax on flights and the number of flights. So it charges in our model 50 pounds per ton of CO2 for air travel emissions, and then charges an additional 50 pounds per ton for each additional flight. So that is kind of, it also, I guess it puts a higher price more generally on air travel compared to the other two models. Okay, so what can we see in the results? So here we see on the top, in the top panel, we see the distribution of the tax burden expressed as a percentage of income. So basically we calculate the tax that each household would have to pay. Then we calculate, what is the percentage of income that this burden constitutes. And we express this distributed over income deciles. Basically, we can see that higher income groups bear a higher burden than lower income groups, with the exception of these models which focus on the number of flights, so the frequent air miles tax and the frequent flyer levy, the dark grey line. They have slightly higher burdens for the first income decile compared to the second and third income decile. And that matches, as we've seen earlier, that the lowest income decile has a slightly higher number of flights than the second and the third income decile. However, because we, as I said earlier, the different taxes, basically the whole amount sort of raised through these taxes differs. And so it's, in my view, almost a bit more informative to look at this graph here, which expresses the tax burden as a multiple of the top income decile. So basically that makes it a bit easier to compare, who's paying more or less sort of in relative terms. And here we can see that actually in all of these models, the lowest income decile certainly pays less than the highest income decile. And in that sense, we would call this type of tax a progressive tax, where we put higher burdens on higher income groups. A couple of other words. So the frequent air miles tax is the most progressive of all, and the air passenger duty, which currently actually does exist in the UK, is the least progressive of these different types of taxes. And I already said about the higher burdens for the lower income deciles for the taxes that focus on the number of flights. So another interesting question then is, just apart from income, which I guess we kind of probably expected, that we could expect this pattern because we already knew that flights are quite unequally distributed across income. But in addition, we wanted to know, so who else might be affected by flight taxes? For this, we used a generalized ordered logic regression, which basically compares the probability of having no flight to having one flight and to having 2 or more flights, which we define as frequent flights, with data from Understanding Society. And rather than showing you the whole sort of regression table, which is really long and has lots of numbers in it, I just try to summarize it here, but I'm more than happy to also talk you through the tables if you like to see them. But what we can see is that high income, we already knew, has a positive and statistically significant association with frequent flights. In addition, characteristics like high education, being in employment, young age, so it's predominantly younger people actually who fly more frequently, and first generation migration background, but not, I have to emphasize, sort of second and third generation migration background, only the first one, having friends and family abroad, car ownership, being in a cohabiting relationship, being female, and also living in London and rural Scotland and Northern Ireland. So all of these characteristics are significantly positively associated with having frequent flights. And so hence these groups would be more affected, especially by the sort of frequent flyer levy type taxes. We see a negative association for responsibility, having responsibility for children, having a disability, and identifying as Asian or Black. So we can conclude for this that flight taxes would mostly burden well-situated groups, but it does put some higher burdens on first-generation migrants and younger people who may also be on lower incomes. And so this has some policy implications. However, an interesting other quick comparison is actually with other types of carbon taxes. Again, we are talking here about hypothetical carbon taxes. So what we did is, because we have the emissions for everything else in the data set, so we have, like I said, emissions for motor fuels, home energy, and total household emissions. And we modeled a very simple, just £50 per ton tax for all of these different types of emissions. And what we can see here is that actually for other types of carbon taxes, lower income groups have a higher burden than higher income groups. Sorry, I hope I have said this correctly. I'm like higher and lower, starting to get a bit confused here. So the lower income groups bear a higher relative burden from the carbon tax than the higher income groups. So this is what we would call a regressive type tax. The only tax that isn't distributed in this way is the flight tax. And we can see it again more clearly in this bottom panel here, where we express the tax burden as a multiple of what the 10th income decile pays. And we can very clearly see here that, for example, taxes on home energy are the most regressive taxes, so put the highest relative burdens on the lowest income deciles, followed by a tax on total emissions. Motor fuels is actually less regressive, much less regressive than a tax on home energy, but it's still a little bit regressive. And then, like I said, the flight emission tax shows, again, a progressive distribution here. So I end with this slide here on the policy implications. So in general terms, we concluded that in contrast to other types of carbon taxes, air travel taxes are neutral or progressive in distributional terms and can therefore be defended from a social justice perspective. However, they do burden frequent flyers on low incomes, some frequent flyers on low incomes, for example, young people and first-generation migrants. Compensating migrants for these higher burdens might be administratively quite cumbersome and intrusive, because you would need to check for things like nationality, family situation, and so on. So in the paper, we say, that is probably quite difficult to do. We do mention in the paper a proposal that Stay Grounded has made when they wrote about a frequent flyer levy. And they proposed an application system for applying, for a higher contingent of flights, for example, based on a family crisis. And in more general terms, one could also say, if we did, for example, increase some of the benefits for low-income groups, that could potentially also compensate some people who are affected by these frequent flyer levies or carbon taxes on flights. I guess some other sort of proposals are that really what we would need to do is improve the train system, especially in Europe, but I would also say in the UK itself, to prevent flights within the UK, but also within Europe and from the UK to Europe, to really sort of reduce frequent flights within this region, where from my own experience, I can say it's fairly easy usually to, let's say it's doable to go by train to destinations in Europe. But at the moment, it's often more expensive to do that, and the booking system is really complicated and puts many people off. So there are many things that can be improved just to make that, much easier and accessible for people. And another thing that obviously came out in our analysis is this thing about the income elasticity, which we found to be lower for higher income groups compared to sorry, there's a mistake here on the slide. So it's lower for higher income groups compared to lower income groups, and that, to my mind, questions potentially the effectiveness of flight taxes, because it means that even though high income groups do reduce the number of flights in response to reductions in income, this is less so the case for compared to lower income groups. And we could see sort of after the recession, shortly after the recession, that actually flights by high income groups increased quite quickly after that. So they weren't really, very much deterred by the recession. So yeah, so that sort of, I guess, raises some question marks about the potential effectiveness of flight taxes, even though we might regard them as socially just. Okay, I leave it here and say, if I can get the last slide up, say thank you. And I'm very much looking forward to your questions.
Thank you, Milena, for your awesome presentation. I think it's very interesting and insightful, and it provides a lot of useful information for us to consider when we study like air travel and how like.
Oh, I think you're muted. Sorry.
Oh.
I think
Okay,
it's happened halfway through.
Between.
Yeah.
All right. So maybe like I should stop here, and I would like to open the floor to questions for the audience, and I